In this video, we will look at the last element of our audio system, mixers. Remember how I said in the signal processor video that a digital signal processor can act as the heart for an installed sound system? Mixers, which can be referred to as mixing consoles, mixing desks, or mixing boards, can also play the role of the heart for varying types of sound systems. In fact, many manufacturers will offer mixers for applications such as multi-track recording, broadcast, post-production, live sound, and stage monitoring. Much like we saw earlier regarding DSPs, microphones, electronic music instruments, CD players, and other sources can enter the system through the mixer, allowing an operator to dynamically mix or balance all of the sources in real time. So what is a mixer exactly? The most important aspect of understanding mixers is understanding the channels. On almost all consoles, the channels are laid out in strips. The signal comes in physically through the back of the device, then passes through the channel's various controls from top to bottom, with the gain or trim at the top and the fader at the bottom. It features inputs where the signals will enter the mixer. The signals then hit the mic preamps to boost that signal. They then flow through to the EQ for controlling the frequency response. They are then routed through the pans and faders to decide where they will fit in the right and left master channels. They then hit the PFL switch, and finally they exit through the master channel faders. A lot of people can easily become intimidated by a mixer, but understand there's just a lot of replication going on. We just saw a flowchart for a very simple one. Now let's have a closer look at a single channel. Once you've learned how a single channel works on a mixer, then you've essentially learned how they all work. We have an input, which is either mic or line, where we connect our mic or instrument, and that goes to the preamp. Many consoles will feature phantom power supplies for each channel, allowing you to use condenser microphones or active electronics such as a direct inject box. A direct inject box, commonly referred to as a DI box, is available with passive or active electronics. Those that use active electronics require phantom power in order to work. The purpose of a DI box is to take a line level signal and convert it into a mic level signal. This can be useful when it is not possible to wire a line level source device into a line level input channel on the mixer. From the input, the signal flows to the mic line preamp, which sets how much of the source signal is available to the rest of the mixer. Too high and the signal will distort as it overloads the channel. Too low and the level of any background hiss will be more noticeable, and you may not be able to get enough signal level to the outputs of the mixer. From the preamp, we go through a 3-band parametric equalizer, allowing fine adjustments to frequencies of the sound source, and then we reach an insert point. An insert point is used to route a source from the mixer through an external effects processor such as a compressor and then back into the mixer. Depending on the mixer you are using, you may find the insert point before or after the parametric EQ, and higher end mixers will allow the operator to choose whether it's before or after. Then the signal hits auxiliary sends, a pan, and a fader for level control of the channel in the master mix. A pan control allows you to decide where to place a channel in the stereo spectrum. In mono applications, you would just leave the pan at the center position, but in stereo applications, you may want to make more room in the mix, so that guitar player who is stage left may be panned more to the right side speakers, allowing for more room for the lead singer in the center. Finally, the signal runs through a mix bus matrix consisting of a pre-fade listen switch, auxiliary switches, and a master left-right switch. The PFL feature, most commonly routed to a headphone output, allows the console operator to listen to the channel before sending it to the master mix. This is useful in troubleshooting purposes. An overload indicator, sometimes referred to as a clip light, indicates if the signal is clipping. An auxiliary send can serve a couple purposes. One is to control the level of the channel in a monitor mix for a musician or presenter, allowing them to hear what they are doing. Using the aux send in this fashion requires communication between the performer and the console operator. Another use for an aux send is to control the amount of the source audio that is being sent to an external effects processor, such as a delay or a reverb. This allows the console operator to either apply a small or large amount of the effect on a single channel while leaving other channels unaffected. Not every instrument should be drenched in reverb. Finally, you can adjust the channel volume with the channel fader. The input gain is usually set once when the source is plugged in and left at that same level. Any volume adjustments are made by the channel fader rather than the gain control. The distance learning classroom environment we've been referencing throughout these videos does not call for an external mixer, but what if this class was taught in a large auditorium like many large seminars in higher education? We will go deeper into the use of a mixer in our instructor-led class, but for now realize it would augment the DSP in the audio system design. For more information about mixers and how to set up your mixing board, visit our YouTube channel at Soundcraft Mixers and check out the Soundcraft Guide to Mixing video series.